When we subtract mixed numbers and we have to regroup, there are two ways you can do this. One way is we change the first number. The second way is we turn them both into improper fractions. For this quick lesson, get some paper because you can't learn it by watching, you have to actually do it. So I'll walk you through the first one, give you some time, or you can pause it, try it, and then see if you're following the right steps. Again, there's lots of ways you can do this. This is just one thought process that makes it easier to understand where we're getting our extra numbers from when we are regrouping. So when you have a mixed number, the first thing you might want to do is do 6 minus 2. But you don't want to do the whole numbers yet, especially with subtraction, because we might need to borrow and regroup our numbers. So what we do want to focus on is the fraction part of it first. So I want to look at my 2/5 fraction, and what I'm thinking is I'm doing 2/5 minus 4/5. So first of all, having it set up in the correct way is really important. I can't do 4 minus 2 because that's just not how subtraction works. Visually, what this is saying is I have 2/5, so 2/5 sized pieces, and I am taking away 4/5. Now, is that possible? Can I take 4/5 away from here? That's like saying I have 2 and I want to take away 4. I can't do that. So when we have regular subtraction, we usually need to borrow from the next place value. In this case, we're going to borrow from the whole amount. So we're going to take 1 from our 6. So I'll cross this out, and that becomes a 5. So now I have this 1. What do I do with that 1? Well, I want the 1 to be represented as a fraction because I want to add it to this fraction here, because what I'm looking for is I'm looking to get more fifths so that I can subtract 4/5 away from it. How do I show 1 as fifths? Well, if you know how to represent a whole, 1 is going to be represented as 5/5. So now I take my 5/5, my 1, and I add it to my 2/5. So I'm going to show that up here. 5/5, which is really 1. So I've taken this and given it over here. Now I add it. So now what your new problem is going to look like is 5, and my new fraction is going to be 7/5. And then I just continue with the rest of the work, minus 2 and 4/5. Once I've regrouped, I know that I have enough and it's just regular subtraction, but I still want to start with the fraction part of it. So 7/5 minus 4/5 will give me 3/5. And then my wholes, 5 minus 2 will give me 3. I check one more time, can I simplify that? Is everything set up properly? It is. So that is my final answer. So try these. Eventually you cut out like almost all of these steps. The beginning part of it is just visualizing, where do I get those extra parts from? Where am I getting more fractions? And you're getting it from your whole amount. And you're putting it in the format in the same sized piece as whatever your fraction piece size is. Okay, so here's a couple more. Okay, so pause it and write down the question. We'll do a vertical one. You can do it horizontal or vertical. They're both whichever way you prefer. Okay, so what we think of first is we focus on the fraction. I'm doing 3/7 minus 6/7. I can't take 6/7 away from 3/7. There's not enough. I need to borrow or regroup. So I'm going to take away from my 8, and that is going to become a 7. I'm taking that 1 that I took away from here, and I'm giving it to my fraction. How do I represent it so that it works best? I'm going to represent it in the same denominator that I have in my fraction. So I'm going to represent this as 7/7. So now I focus on this. So one more time, I took 1 from here, I gave that 1 to my fraction. Now I just continue with this. So I have 7. And what do I get when I add these fractions? 3/7 plus 7/7 is 10/7. And I know that's an improper fraction, but we leave it that way so that we have enough to finish the problem. And then at the end, we'll convert it if we need to. At this point, we continue with the subtraction. So we have 5 and 6/7. So if we say, all right, 10/7 minus 6/7 is going to be 4/7. and my whole amount, 7 minus 5, is 2. This is already in the simplest form. It's already in the proper format, so that is it. Okay, pause it, write it down, try the problem, and then come back and check if you're doing the right steps. So again, lots of ways you can solve this. This is just one thought process, and if you can do it in your head eventually, that's totally fine. But remember, we start with a fraction first. Can I do 3/8 minus 6/8? No, I need to have more of my 1/8 sized pieces. So I'm going to borrow. I'm going to take from the 12. This becomes 11. This 1 that I had, I want to represent it as a fraction that has the same denominator. So I'm going to take this 1 and give it to my fraction. So now I focus here. After this, all I'm doing is rewriting my question and continuing. So now I have 11. My fraction here is 3/8 plus 8/8, which is 11/8. And the rest of my problem is the same. Then I stick with my fractions first. So 11/8 minus 6/8 is 5/8. And then my whole amount, 11 minus 5, is 6. And then I do my last check. Is there anything I need to simplify? Is it in the right format? It looks good, so I'm done. Write it down, pause it, do the work, and then come back and check. So first step, look at the fractions. We're saying 11/16 minus 14/16. So 11 minus 14. Can't do it, we need to borrow. Take from the 15, it becomes a 14. The one that we took represented as the same denominator as the fraction I want to give it to. So this is going to be 16/16. Then I rewrite that whole section here. So I have 14 and 27/16. And then I continue. And then at this point, it's just regular subtraction, still starting with the fractions first. So 27 minus 14 is 13/16. And then 14 minus 12 is 2. I check if I can simplify anything. I can't. So this is my final answer. Here's the last one. Write it down, do the work, come back and check it. Starting with the fractions, I have 6/9 minus 8/9. I can't do that, so I'm going to borrow from my 12. This becomes 11. This 1 that I took from here, I'm representing it as a fraction using the same denominator. So I focus on that. Then I rewrite this, 11, 9 plus 6, 15, 15/9 minus 8 and 8/9. Then it's regular subtraction. 15/9 minus 8/9 is 7/9. And then 11 minus 8 is 3. I can't simplify that. I'm done. So this is my final answer. Okay, so all of these examples, whenever you need to regroup, you're always taking from the whole. You're giving that 1, you're giving it to the fraction, and you're giving it in the form that matches the fraction. So whatever the denominator is, I want to write my 1 as a fraction that matches it so that I can add those together. And that gives me the amount that I need to finish my subtraction problem. So this is the way, and when you get faster at it, what you think in your head, like eventually maybe you don't need to write this part and you can just add that in your head and go straight to this part. That's fine too. Another method is to turn both of these into an improper fraction and then do the subtraction, and then at the end turn it back into a mixed number. That's a lot. Well, that might be a method that's better if you like that more. So here's one example of that way. So, and then that'll be it. Okay, this method works when you have smaller numbers, but when you have larger numbers and you use this shortcut method, it can be a lot of extra steps. But what the shortcut method would say is, let's turn this into an improper fraction first. So we do 8 times 5 is 40, plus 3, so we get 43 fifths. So basically what I've done is I've turned my mixed number into all of its fifth-sized parts. So I have 43 fifths, that's like 43 1/5 sized pieces, minus, I turn this into an improper fraction, so 5 times 5 is 25, plus my 4 is 29 fifths. So these now are all in fifth-sized pieces. Then I can do my subtraction, so 43 minus 29. If you can't do that, do it on the side, not a problem. 43 minus 29, and you will get 14. So now I will be left with 14 fifths. In this case, we don't ever want to leave an answer as an improper fraction, so I would need to turn this back into a mixed number. So what this is telling me again is how many wholes do I have in here? This is another lesson. If you need a review, go find it and review it. But what this is as a mixed number, or as division basically, 14 divided by 5 is going to be 2, so that's 10. Because what I'm saying in my head is 5 times what is 14? Well, 2 times 5 is 10. How many leftover fifth-sized pieces will there be? There will be 4 fifths left over. So another way to think of this is how many wholes are in here. Every 5 fifths is a whole, so there's a 5 fifths and another 5 fifths, that's 10 fifths. What's left over? The 4 fifths. Okay, so this step is totally fine if you want to do it this way. It's just when you get to larger numbers and you want to turn it into an improper fraction, it's a lot of math you need to do, and you have to turn it back into a mixed number at the end. But if you like it and they're small numbers, totally fine.